Guys, welcome to a new video. We want to solve this problem. A hunter directs his uncalibrated rifle toward a monkey sitting on a tree at a height h above the ground and at distance d. The instant the monkey observes the flash of the fire of the rifle, it drops from the tree. Will the bullet hit the monkey? Okay, we have this illustration. Here we let the rifle be fixed at the point 8 right here in the direction AB. We have A and B. Alright? The angle that this direction makes with the horizontal is alpha, as is shown in the figure. The monkey is sitting on the top of the tree right here at the point B. The height between the monkey and the floor initially is h. The bullet follows, when the bullet is shot, it follows the path that is shown here on the dashed line. Alright? This path. The path is parabolic and reaches the point D at the distance h at the time t. So to start solving this problem, we want to write the vertical and horizontal components of the velocity at the beginning of the problem. So initially we will have Bx equal to V cosine of alpha, and we will have By equal to V sine of alpha. Okay, as we know, the bullet is shot with velocity v. Here we can see that. Okay, we will call these equations number 1. Let the bullet reach the point D, which is vertically below the point B. So the bullet is shot and it reaches the point D and is vertically below the point B at the time t. The coordinates of the point D are dh. Okay? Because the horizontal component of the velocity is constant, as we know, for a parabolic motion, the horizontal component is constant at any instant of time, we will have that the distance d is equal to the velocity along the x direction multiplying the time. So, but from equation 1 we know that velocity along the x-axis is equal to v cosine of alpha multiplying the time. But according to the geometry of the problem we have, let's go to the illustration real quick. I will call this point at the bottom of the tree point C, and I have the triangle here. I will draw a triangle real fast. This is alpha, this is A, this is B, and this is C. This is D and this is S. Okay? So, according to this triangle, we will have that cosine of alpha is equal to adjacent leg dividing the hypotenuse. And this is the dividing S. Okay? Then I replace this term into this part of this equation, and I will have D is equal to V cosine of alpha, but cosine of alpha is D dividing S multiplying the time. This D cancels out with this D, and I will have that 1 is equal to V T dividing S. Then I will write this last equation like clearing the time t, and I will write t is equal to s dividing b, where s is equal to ab. I will call this equation equation number 3. I call this equation equation number 2. I forgot this one. Okay, so if we go to the illustration, AB is equal to S. That's what I have right here. Now, the vertical component of the velocity is reduced because of the gravity, and we can write this vertical component as the following expression shows. Y is equal to h, and this is equal according to the motion along the vertical component, Vy minus 1/2 of the gravity multiplying the time square. This is equal to, okay, let's go back real quick to the illustration. We know that the component is vertical, and this is equal to V, according to equation 1, V sine of alpha multiplying the time minus 1/2 of the gravity multiplying the time square. Okay, I will call this equation number 4, but by the geometry of the problem, we have the triangle ABC as we already know, and I can write according to this triangle that we already know that the sine of alpha is equal to the opposite leg dividing the hypotenuse, and that's equal to h dividing s. What is h? Is this distance, right here, this distance. From equation 3, we have that the time is equal to s dividing v. All right, then I can write equation number 4 as follows: equal to v, Vy is v sine of alpha, t minus 1/2 of the gravity multiplying the time square, and this is equal to h is equal to, okay, v sine of alpha, but sine of alpha is h dividing s multiplying the time, but time is s dividing v minus 1/2 of the gravity multiplying the time square. This s cancels with this s. These velocities, they cancel each other as well, and I will have h is equal to h minus 1/2 of the gravity multiplying the time square. Then I will have t 1/2 of the gravity time square is h minus h. Okay, so what I do here is I invert the signs of each side of the equation, this is negative and this will turn positive. It's like I multiply both sides of the equation by -1, and I will have gravity dividing to times square equal to h minus h capital. Finally, I want to clear the time, and I will have times square is equal to 2h minus h capital dividing g. Then I will have t is equal taking root square on both sides of the equation is equal to root square of 2h minus h dividing the gravity. This is the time that the bullet takes to reach the point D. The quantity h minus h capital is the height to which the monkey drops from the tree. Then the bullet would hit the monkey independent of the bullet's initial velocity. So if we go to the illustration, we see here that the bullet is shot. At the time t, the bullet reaches the point D. Okay? The bullet travels this distance along the parabolic path, but the monkey drops from the top of the tree and it travels this distance. So at the time t, the bullet reaches the point D, right? But at the same time t, the monkey travels the distance h minus h capital. So they meet at the same time at the point D. So the bullet hits the monkey. Independent of the initial velocity of the bullet, it hits the monkey at the time t. So the monkey won't survive. The monkey will die. Sorry, monkey. Okay, guys, this is the problem that I wanted to show you today. This is a problem from Physics 1. Hopefully you like it. Please, you can subscribe to my channel if you like my content. You can share this content with your friends and give me a thumbs up. And I appreciate it because you are watching my videos. See you in the next video. Bye.